Pi. This simple symbol represents a profound concept. It's a mathematical constant, the ratio of a circle's circumference to its diameter. We write it as pi, a letter from the Greek alphabet. Pi is an irrational number. Its decimal representation goes on forever, never settling into a repeating pattern. This endless nature makes pi fascinating and mysterious. Pi's importance extends far beyond geometry. It pops up in various areas of mathematics and science. It helps us understand the universe from the smallest to the largest scales. Let's embark on a journey through the history of pi. We'll explore humanity's quest to understand this enigmatic number. Early civilizations observed the peculiar nature of circles. They noticed that the ratio of a circle's circumference to its diameter was constant. Ancient Babylonians and Egyptians around 2000 BCE made the first attempts to calculate pi. The Babylonians approximated pi as 3.125. The Egyptians used a value of 3.16. These were remarkably close for their time. These early estimations were based on practical observations and measurements. They used ropes and rods to measure circles. Their methods lacked the precision of later mathematical techniques, but their efforts marked the beginning of our fascination with pi. The ancient Greeks made significant strides in understanding pi. They were pioneers of geometry. They developed rigorous methods for mathematical proofs and calculations. Archimedes of Syracuse, a brilliant mathematician and inventor, devised a groundbreaking approach. He approximated pi using polygons. Archimedes inscribed and circumscribed polygons around a circle. He calculated their perimeters, which gave him upper and lower bounds for pi's value. He continued to increase the number of sides in his polygons. This process led him closer and closer to the actual value of pi. Another Greek astronomer, Ptolemy, later calculated pi as 3.1416, a remarkably accurate value for his time. While the Greeks were making significant progress, mathematicians in other parts of the world were also exploring pi. Chinese mathematicians made notable contributions. Zhu Chongzhi, a 5th century mathematician and astronomer, used a method similar to Archimedes. He used polygons with up to 24,576 sides. Zhu Chongzhi calculated pi to be 3.141596, an accuracy that wouldn't be surpassed for centuries. In India, Madhava of Sangamagrama, a 14th century mathematician, discovered an infinite series representation of pi. This groundbreaking work laid the foundation for later developments in calculus. Section 5. Pi's European Journey. During the Renaissance, European mathematicians picked up the torch of pi. They were inspired by the works of the ancient Greeks and the discoveries from the East. Rudolf van Keulen, a German mathematician, dedicated much of his life to calculating pi. He used Archimedes' method with polygons having millions of sides. Van Keulen calculated pi to 35 decimal places, a remarkable achievement for his time. His value was engraved on his tombstone. Later, mathematicians like John Wallis and Isaac Newton developed new formulas and methods. They further refined the calculation of pi. Their work paved the way for the modern era of pi calculations. Section 6. The Pi Machine. The invention of computers in the 20th century revolutionized pi calculations. Computers could perform calculations at speeds unimaginable to humans. They became the ultimate tool for chasing decimal places of pi. With each passing decade, computers pushed the limits further. Today, we know pi to trillions of digits. The current record stands at over 100 trillion digits. These massive calculations have practical applications in fields like cryptography and computer science. But they also serve as a testament to human ingenuity and our relentless pursuit of knowledge. Section 7. Archimedes' Polygons. A closer look. Let's take a closer look at Archimedes' method for approximating pi. Imagine a circle. Now imagine drawing a square inside the circle, touching all its sides. This is an inscribed square. Next, draw another square outside the circle, with the circle touching the middle of each side. This is a circumscribed square. The perimeter of the inscribed square is less than the circle's circumference. The perimeter of the circumscribed square is greater. Archimedes realized that by increasing the number of sides in the polygons, he could get closer to the circle's actual circumference. He used hexagons, octagons, and polygons with even more sides. Each time, the polygons hugged the circle more tightly. By calculating the perimeters of these polygons, Archimedes narrowed down the range within which pi's value must lie. This method, though tedious, was remarkably accurate for its time. Section 8. The ubiquitous pi. Pi is not confined to the realm of abstract mathematics. Its applications are vast and diverse. In geometry, pi is crucial for calculating a circle's circumference, area, and volume of spheres. In trigonometry, pi helps define angles and trigonometric functions. Pi appears in calculus when dealing with curves, waves, and periodic phenomena. Its presence is felt in physics, where it helps describe everything from the orbits of planets to the behavior of light and sound waves. Engineering and computer science rely heavily on pi for calculations involving signals, image processing, and data analysis. Section 9. Pi in our culture. Pi's influence extends beyond the world of science and mathematics. Pi has permeated popular culture, becoming a symbol of knowledge and the infinite. We celebrate Pi Day every year on March 14th, 3.14. It's a day for math enthusiasts to celebrate pi with what else but pi? Pi has made appearances in movies, TV shows, and even music. It serves as a reminder that mathematics is not just about equations and formulas, it's a language that helps us understand the beauty and complexity of the universe. Section 10. Pi's enduring legacy. From ancient estimations to modern supercomputers, the journey of pi has been one of curiosity, ingenuity, and the pursuit of precision. Pi's decimal representation may be infinite and non-repeating, but it has helped us unlock countless secrets of the universe. As we delve deeper into the mysteries of mathematics and science, pi will continue to be our guide. It will inspire us to explore the unknown, push the boundaries of knowledge, and marvel at the elegance and interconnectedness of the cosmos.